This lecture is about the base plotting system in R. Previously we talked about the three different plotting systems that R has, the base plotting system, the lattice system, and the ggplot2 system. So here I'm going to talk about the base plotting functions, and which is the kind of most commonly used system for plotting in R. All of the core plotting and graphics engine in R is encapsulated in the graphics package and the GR devices package. The GR devices package contains all the code for the graphics devices, including the screen devices like X11 and Windows and Quartz, as well as file devices like PDF and PostScript. The graphics package contains the plotting functions, so very basic functions like plot, hist, box plot, and many others. And so this will be the core plotting system, what we call the base graphing system. The lattice system is encapsulated in the lattice package, and that uses another package called grid, which is kind of a low-level graphics system that's kind of an alternative to the base graphics system. We usually don't call the grid package directly, only indirectly through packages like lattice or ggplot, and the lattice package we'll talk about in a separate lecture. So, in the process of making a plot, there are a lot of considerations that you have to make in terms of where will the plot be made? Will it be made on the screen? Will it be sent to a file? How will the plot be used? Is it for viewing on the screen temporarily? Is it going to be in a web browser? Are you going to be printing it in a paper? Does it need to be publication quality? Are you going to use it in a slideshow or presentation? So these are kind of questions that you need to think about when you're making a plot. Another question that you might want to think about is there a large amount of data that's going to go into this plot? Or maybe just a few points, or is it an image, or is it a line drawing, or is it something like that? And then lastly, one question that's worth asking is whether you need to be able to dynamically resize the graphic, because you may want to use something like a vector format if it's sending to a file rather than a bitmap format. So those are a couple of questions that you want to make as you start making a plot. The other question, of course, is what graphic system you want to use. There's base, lattice, and ggplot2. And the reason why you have to ask yourself this question is because you can't really mix the three different systems. The three systems, roughly speaking, are, the base graphics has this kind of piecemeal construction where you put things together one by one through a series of function calls. The lattice system creates entire plots out of a single function call, so everything kind of has to be conceptualized from the get-go. And the ggplot2 system kind of combines concepts from both lattice and base. So in this lecture, we'll be focusing only on the base plotting system, and we'll be talking about creating graphics on the screen device only. So in base graphics, you're essentially creating two-dimensional graphics, and you have to do it in a two-phase process. The first process initializes the new plot, and the second phase, I should say, annotates or adds to an existing plot. And so there are a number of functions that are useful for initializing a plot, and then there are a separate set of functions that are useful for annotating a plot. So the plot function or the hist function are two examples of functions that are used for initializing a plot. And what they do is that if there's no graphics device open already, it will launch a graphics device. And typically this will come in the form of a window that pops up on your screen. And then it will draw the plot on that new device. The plot function is a generic function in R, and so it can behave differently depending on what kinds of data you pass to it. If you don't pass it a special type piece of data, so if you just pass it X and Y, or for example vectors, then you use what's called the default method for plot. This default method has a lot of arguments, and you can look at the help page for plot and see what those arguments are. For example, you can set things like the title, the x-axis label, and the y-axis label, and many other types of details. In general, the base graphic system has many parameters that you can use to set and tweak to make your graphics look exactly the way you want them to. This is kind of it's a double-edged sword, because there are a lot of things that you can customize, but of course then there are a lot of things that you have to set that are not automatic. And so most of these parameters are documented in the help page for PAR, so you just look at that help page, you'll see a lot of parameters there. It wouldn't hurt to try to memorize this help page, of course, but it's always there for you if you don't. So here's a basic graph that is made using the base graphic system. Here I'm using the hist function, which creates a histogram, which is a kind of a one-dimensional plot. And so here I'm loading the air quality data set from the datasets package, and I'm making a histogram of ozone. And so you can see that I'm not setting, there are other arguments to hist, but I'm not setting all of them. And so I'm just using the defaults for whatever there is there for hist, and it makes a simple histogram. And so this, if my graphics device had not been open in R, it would have opened the graphics device and then put the histogram in there. Another fundamental type of plot is the scatter plot, of course, and this can be created using the plot function. Here I'm using the same data set, but I'm making a scatter plot of ozone versus wind. And so you can see the default plotting, since I don't specify any other arguments to the plot function, I'm using all the defaults here, and the default plotting symbol is an open circle with kind of a white background. And then finally, this is another function that initializes a plot. It's the box plot function. Here, and you can see I'm making a box plot of the distribution of ozone by month. So you can see the box plot function uses a kind of formula notation where I'm saying on the y-axis I want ozone, which is the left-hand side of the tilde, and on the right-hand side I specify what I want on the x-axis, which in this case is the month. And so the month is to kind of divide it into a categorical vector. Categorical variable, so for the months of May, June, July, August, and September. And here you can see I specify what I want the x-axis label to be through xlab, and the y-axis label through ylab. So there are a couple of key base graphics parameters that are useful to kind of keep in the front of your brain or at the top of your head, whatever you want to call it, because you tend to use them quite often. The first one is the PCH, or the plotting character or plotting symbol. You notice that the default in the previous plots is the open circle, but you can change this to be something else, and so the PCH can take two types of arguments. You can take a number, which refers to a table of kind of built-in symbols, or it can take a character. So it can take a character element, which will just plot that character on the screen. So if you give it the letter A, for example, then it will use as the letter A the plotting symbol for all your data points. So sometimes this is useful for kind of self-labeling a plot. So you can say that all the A's represent one group and all the B's represent another group. The LTY is the line type, and so if you're plotting things plotting data that are lines, this will specify whether it's a solid line, a dashed line, or a dotted line, or a dot-dash line, or etc. The LWD is the line width. So a lot of times you want to control the line width, depending on how the plot's going to be used. For example, if the plot's going to be in a presentation where lots of people are going to be sitting in the back row, then you usually want to have very thick line widths so they can see the lines. But if it's going to be in a publication where it's going to be in a journal or printed, and people are going to be looking at it much closer, then you don't need such thick lines. The col is the plotting color. So this is the color that the plotting symbols will appear on the screen. Sometimes you like to customize that. You can specify colors using either a number or a string, which is like a word, or you can use a hex code that's written in character format. And the colors function will give you a list of colors that you can specify by name. So you can see there are a lot of colors there. And then xlab and ylab let you specify the x-axis and y-axis labels. And that's very useful for annotating plots. And a couple other base graphics parameters that can be useful that you can set in the par function, because the par function is used to specify global graphics parameters. So these will be the same in every single plot that you make. Of course, you can usually override the global graphics parameters by specify them in each function call. So if you don't like, for example, the background color, you can change that within a given function. However, other parameters like the margin size or the MF row or the MF call, these cannot be changed within the plotting function. They have to be changed using the par function only. And so the LAS is the orientation of the axis on the labels. So if you like all the labels on the axis labels to be kind of horizontal or perpendicular to the graph, you can change this. BG is the background color for the plot. The margin size, sometimes it needs to be modified. If you have a very complex y-axis or x-axis label, you might want to make the margin a little bit bigger to accommodate that. The outer margin is important. If you have multiple plots per page, and you want to have a kind of a label that's in the outer margin that kind of covers the entire plot. And the MF row and the MF call control how many. If you're having multiple plots on the screen device, and for example, you have a matrix of plots, and it controls how many plots will appear per row and per column. So you can see what the default values for some of these global graphics parameters are by just calling the par function with the name of the parameter and no other arguments. So you see the LTY, the default is a solid line. For color, the default is black, and for PCH, the plotting symbol is 1, which corresponds to a open circle. For BG, the background is transparent, so there's really no background color. And then for the margin, you can see that there's 4 numbers here. And each one of these numbers refers to one of the margins of a plot. And if you think of the bottom of the plot as the first side, and then the left-hand side is the second side, and then the top is the third side, and the right-hand side is the fourth side. So you can think of starting at the bottom, going in a clockwise direction. Those are the 4 sides of a plot. And you can see that the bottom margin gets a size of 5.1. And you can roughly think of this as 5.1 lines of text that could be in the bottom margin. And then the left-hand side is 4.1, the top is 4.1, and the right-hand side is 2.1. So you can adjust those margin sizes if you need to accommodate your plot to make more or less space in those margins. And then the MF row defaults to 1, 1, which means 1 row and 1 column, so that's just a single plot.